So in this video, we're going to have a look at conversion of meters from meters squared to liters, kiloliters and megaliters. And then we're also going to look at calculating the rate of change using this scenario that we've got here. So an oil tanker has a capacity of 40,000 meters cubed. So firstly, we have to find what is the ship's capacity. Start off with liters. So I've written here our little formula, our conversion from meters cubed to liters. So if 1 meter cubed is 1,000 liters, we actually need to rewrite this here. To convert, we'd go 40,000 multiplied by 1,000, which goes equal to C for capacity. So our capacity of the ship in liters is equal to 40,000 times 1,000. That gives us 40 million liters. So 40 40,000 and then another multiply by 1,000. So we're going to add 3 more zeros on. So that's 40 million liters. So let's write that L for liters. So now what we have to do is convert these liters into kiloliters. So we know that there's 1,000 liters in 1 kiloliter. So what we need to do, we need to divide. Let's divide that by 1,000 to get our kiloliters. So kiloliters is equal to 40,000. Another way that we can do this is 1 meter cubed is equivalent to 1 kiloliter. So you'll see that we've got the same amount that we had at the start here, 40,000. And then we do the same process again to find our megaliters. So we need to divide again by 1,000 because there are 1,000 kiloliters in a megaliter. So let's go divide by 1,000. Divide by 1,000 will give us our megaliters, which there will be 40 megaliters. So that's question A done. So look at question B here. If the tanker leaks oil at a rate of 300,000 litres per day, how long will it take for all the oil to leak out? Assuming that the ship started with full capacity. So it started with 40,000 meters cubed. But since as this is here is going in litres, let's use our litres value here. So 40 million litres. So the way that we would do this, you'd need to write this out as an equation. So let's do our y. So we'll have y is equal to the amount of oil that passes through the ship. So y is equal to, so it's 3,000 litres, sorry, 300,000 litres per day. So go 300,000 litres, and that's per day. So let's do D for day. So this is our formula here. So what we need to do now is now we've got our formula written down here, we can move that away. Let's work on this formula. So before we do, we'll go back. So remember we're assuming that the ship starts with a full capacity. So if we're all working in the same unit, so litres, it'd be 40,000 meters cubed converted into litres. So that's, remember we did this before, 40 million litres. So that's our Y values. We want to see how far, so how long it takes for 40 million litres to pass and to leave the ship, which is our Y value, how much oil leaves the ship. So we'll start from here. Let's rewrite that as 40 million 40 million is equal to 300,000 so that's 300,000 multiplied by D. Now to get rid of that 300,000, so to get the amount of days for D for days, to get the amount of days we have to get that D by itself. So that's a multiplication in here. So we need to divide both sides by 300,000. 300,000. Then we also have to divide this side as well by 300,000. We divided both sides by 300,000. That will give us a value of, let's put it here, 40 million will give us a value of 133. That's going to be 0.33 reoccurring. So this little dot up here means that it's reoccurring. That means those threes are just going to continue on forever. Is equal to D. So it would take 133 and 1/3 of a day for all of the oil to leak out of the ship.